Okay, so now that you've mastered ionic bonds, we are going to move on to a new kind of bonding called covalent bonding. This is Unit 7, and again, I'm going to try to follow along with the PowerPoint pretty closely. When we talked about ionic bonding, we talked about how it was a metal and a nonmetal. We've also talked about two metals mixing together to make an alloy. So with covalent bonding, what we're talking about is two nonmetals. Now, for the record, you know there's always an exception. It can also be a nonmetal and hydrogen, because as we've said all along, hydrogen is just his own special guy that kind of follows his own rules. So what's happening with these covalent bonds? Nonmetals are on your right side of the periodic table. So you're talking about 5, 6, 7 valence electrons. Okay? If I have that many valence electrons, I am not going to want to give up any. That doesn't make any sense to give them up. Giving them up doesn't make me more stable. So if I have two nonmetals that want to join together and each of them have this many valence, it makes absolutely no sense that they would actually give away their electrons. So instead what they do is in a covalent bond, we see the sharing of electrons. They cannot give them away, but they still want to be stable. They want those 8 electrons. By sharing, both of them get to count those electrons toward the noble gas configuration. So the easiest example to help you visualize this is actually 2 fluorine atoms. Fluorine, if you look at your periodic table, has 7 valence electrons. So for simplicity's sake, I'm going to draw him that way. And then if I have another fluorine, he also has 7 valence electrons. And I'll draw him like this. So if you're a pretty visual person, you can sort of see what's going to happen already. But this guy has 7, he's not stable. Okay? This guy has 7, he's not stable. But if I move these two closer together and I allow them to share those 2 electrons, now all of a sudden what I have here is, there's one fluorine, oops, and then I'm going to pull my second fluorine nice and close. And when I pull him nice and close, all of a sudden they get to share this pair of electrons that's right there in the middle. So now when I look at it, what I see is this fluorine has 8 electrons. When I share them, I get to count them. Okay? Now, here's the fun part. This fluorine has 8 electrons. 2, 4, 6, 8, going all the way around it. So that gives me 2 stable fluorine electrons. So when we're looking at covalent bonding, there's a couple things that you may see. One is just a molecular formula. Okay, a molecular formula you've been working with all along, you just didn't realize it. It's just showing you the number of atoms in each molecule. So you were just looking at F2. You've heard of H2O. Okay, that's the molecular formula. That's an H, I promise. The second thing we're looking at is Lewis dot diagrams or Lewis structures. The Lewis structures are what you were just looking at on the previous slide. Okay, that's when I have my dots. Okay, and we're looking at how everything is joined together. The third, which is new with this unit, are structural formulas. Now, you guys saw some structural formulas when we did the tie-dye lab. But what a structural formula does is it replaces any shared pair of electrons, like that one, with a line. So if I take that F2, okay, a structural formula is going to show these F's joined together. Now, most of the time, structural formulas will still leave on the unshared pairs of electrons. So all those outer dots will still be there. It's just the ones that are shared that get replaced with a dash, okay, or a line. So when you see a line, it represents a shared pair of electrons, okay, just like that one right there. And then the last thing that we're going to look at, and this will be late in this chapter, we're going to look at models. Models are cool because they are 3D. And the fact is, this is not in 3 dimensions, and 3 dimensions changes everything. So today, we're only going to talk about single covalent bonds, okay? And then the next video, we'll talk about doubles and triples. With singles, you have to remember you're going to have either 2 nonmetals, or you're going to have a nonmetal and hydrogen. Those have to be your pieces. And because it's a single bond, I am sharing 1 pair of electrons. It's going to be 1 from one atom and 1 from another. This is not ionic, okay? So we are not transferring electrons. We are sharing them, and that's important. So the cool thing about these is if you like jigsaw puzzles, you will really like these covalent bonding. The whole idea is you have to be given the formula. There is no crisscross or anything with balancing charges. I will give you the formula, and then you have to put the pieces together to make everybody stable. So you have to remember a couple basic rules. Okay, most every atom you're going to look at needs 8 electrons. Hydrogen and helium, of course, are the exceptions. Hydrogen and helium, as you guys know, only need 2, and that makes them stable or happy. To get started, okay, if you see a carbon, it is almost always going to be in the middle. Okay, beyond that, the other advice I have for you is if there is one of something, put it in first. And I'll show you what I mean here in a second. All right, lots of times when we have formulas, what we see are things like H2O or PF3. Okay, whatever there's one of, okay, there's one oxygen here, there's one phosphorus here. Start with that first and then work the other pieces around it. Okay, the only other rule or kind of advice I have for putting these puzzles together is save your H's for last. Because you know hydrogens can kind of cling on to any electron that's there, you always want to save him for last and kind of fill in whatever spaces you have left. So let's look at water as an example. Water's a great one. You know the formula H2O. If you look at the rules I just gave you, you know you want to start with oxygen. Okay, so I'm going to put oxygen here. I'm going to do my dot diagram. 4, 5, 6. Now, I have the advantage in this video where I can change colors. But if you can't change colors, sometimes a really easy thing to do is use X's instead of another color just so you can see where the electrons are coming from. Because what I really have here is I have 2 hydrogens that I have to put on. Now, you have to remember, this electron right there, he's not locked on that side. This is just a model. So we can rotate these H's around however we need to. And what we're trying to do is have them share. So I'm going to take one of them, right, and I'm going to put him over here on this side. And when I do that, and he shares a pair, okay, that makes that hydrogen stable. So I'll erase that arrow. Now I have another hydrogen. You can probably already see what's coming. I'm going to slide him right over here. And now I'm going to take a look and see how my puzzle pieces went. Okay, I'm following the rules here. These guys are sharing electrons, 1 from each. The hydrogen has 2, so he's happy. This hydrogen has 2, so he's happy. This oxygen has 8, so he's happy. That's really what you're doing with these single covalent bonds. To make a structural formula, remember we just replace the shared pairs with lines. Okay? Now, quick note. Some of you guys may be thinking from biology, hang on a second, I know this isn't supposed to be in a straight line. I know this thing is bent. I know it looks like Mickey Mouse. You're right. And we're going to learn why it looks like Mickey Mouse later. But for your structural formulas, we're not really worried about representing the 3D shape. In other words, if you draw it like that, it is correct. If you were to draw it like this is correct. Because all these are is 2-dimensional representations of something. They're actually not 3D, and they're not showing 3D. Okay, so dot diagrams take a bunch of practice. You guys have several in your notes. I'll do one more in this video from the practice problems you have on the PowerPoint to help you out. Let's try CHF3. Okay, I'm going to pull one of the harder ones out. Okay, actually we'll do this one and one more. So follow the rules I gave you before. Put carbon in the middle. Carbon has 4 valence electrons. Carbon does a lot of covalent bonding. Other thing I told you was save your hydrogen for last. So I'm going to go ahead and start fitting my fluorines in here. I'm going to have one on this side. Okay, fluorine has 7 valence electrons. I'm going to try putting one on this side. 7 valence electrons. And then I'm going to put one over here with 7 valence electrons. Okay, so that takes care of my carbon. That takes care of my 3 fluorines. Now all I got left is my hydrogen. And I'm going to put that hydrogen right up here. Okay, when I double check my electrons, my fluorine has 8, this fluorine has 8, this fluorine has 8, this carbon has 8, this hydrogen has 2. Everybody's happy. Okay, another example that's on there, and this one can be a little tricky, is C2H6. Now this gets hard because I told you if there was carbon, put it in the middle, but you've got 2 carbons. So when you see that, my advice is carbon likes being in chains, so let it be in a chain. Okay, I'm going to do this one with X's and dots so you can see what happens when you don't have colors. So I'm going to put my two carbons side by side. Again, they've got to be sharing that pair of electron. And this is where the X and the O's kind of help because you can really see that shared pair right there in the middle. Now, I got 6 hydrogens I got to deal with. So I'm always looking for a single place to put somebody on. So there's 1. There's 2. There's 3. You can probably see where this is going. There's 4. There's 5. And there's 6. Okay, so it's just putting the puzzle pieces together, and if we were looking at a structural formula, what we would have on this one, okay, we would replace all of our shared pairs with lines, and in this case, everything is a shared pair, and that's my structural formula. So we'll be back in the next video dealing with double and triple bonds.